Hello everyone, welcome to my channel Cryptoware. And today we are going to get started with the alternate days reverse engineering challenge, which we left off few months back, I believe. And today's challenge is Get Simple, Crack Me Medium Hard. So I'll share the link of this challenge in the description below, and you can follow whatever I'm doing, or you can try to solve it on your own, and then you can check like if our solutions or the approach was same or different. So let's get started. So first things first, let's understand how this application runs. So we'll just double click on it and see that it asks for a key. So I'll just put anything over here, like I'll just put Shruti over here, and I'll see nothing is visible. It just goes. So what I'll do is I'll open it in CMD and I'll try to run it again. Okay, let me just write my name again, and it says incorrect. So this is a command line challenge. So once you open it properly or run it properly through command line, you will be able to see the output over here. Now we see that it asks for an input, which is the key, and it gives us the result whether our key is correct or incorrect. That is what I'm assuming it to be doing. A few other things that we may need to know about the challenge is like the difficulty level is 2.3, which is pretty much normal. We have solved difficulty level of 2. We have also solved some of 4 also. The quality is good. This is the architecture. So we will need to open it in 64 debugger. And yeah, that's it. C++ is the language that has been used. Also, other than that, we have done this previously. We can open it in PE Studio as well. So there's nothing harm with that. With PE Studio, since this is a challenge, we are not looking for like which scanners are detecting it as malware. We are trying to identify the architecture and some other details that we may get, which we may not have gotten from here. So we are trying to get it from P Studio. So never mind, we will not need anything else. We will also need to see the description, which says that it is a medium hard crack me with anti-debug checks, obfuscated strings, and key. So this is what we need to look for. So let's get started with it. We can open it in x64 debugger directly. Let's try. Okay. So we'll see again, we'll follow our ritual, like we'll try to see what strings are available. So we'll search for all user modules and string references, anything interesting. So here we can see password. So we'll just put a breakpoint over there. We see some base 64 strings over here. So we'll put a breakpoint over there also. We need to understand what is happening there. There is anti-query information process. We'll put a breakpoint over there also because we do not see any other calls over here. So maybe this could be something very interesting. Another thing, we have already gotten a hint that it has some anti-debug checks. So we can assume that it is having base 64, sorry, it has is debugger present call as well. We can assume that. Let's get back over here. We'll go to references. Sorry, we'll go to symbols. We'll go to kernel 32 and we'll see if we have is debugger present, or just we'll write debug. And yes, we have is debugger present. So we'll put a breakpoint over there. And anything else do you think that is important for us? Check remote debugger present. That could be interesting, but let's see. We'll put a breakpoint over here also. There are lot of debug things that we can see, but right now we are mostly interested in these two. We have solved for is debugger present before, but what we can do, we can check for check remote debugger present as well, but let's see if we get a hit or not. So let's start. We'll just run and see the entry point. Okay, it asks for password. We'll see that anything is happening here. Nothing. We'll just keep going. We can directly run to see where it is, where it stops. Okay. Now a breakpoint is hit over here, and we see that this is the base 64 encoded string over here. So what I'll do is I'll copy the selection to, or I'll just copy it and I'll open it in Notepad. What I need right now is this base 64 encoded string. Like, what does it mean? Is it some sort of password or anything else? So we'll just open base 64 decode. You can do it offline as well. Okay, we'll just decode it. Okay, so it says enter key. Okay, so this is not like it is not any password or anything. It just says enter key. So I'm assuming these all also to be something of that sort, maybe some sort of instructions, and these necessarily may not be the password, but we will try, we will check, we will not miss out on anything. So we'll just copy this as well, because we see three more strings. So we can actually copy them and we can see what they mean. So I'll just copy the selection and I'll just put it here. And I'll do the same with the other two as well. Since there are just few strings, so we can actually try doing that. There's nothing harm with that. We'll get an idea of what is present over there. We'll put them all together and we'll see what they mean. This just okay, no, this is not the okay. I'll just select and I'll just put them all together. Okay, there's one thing that we can see that it says password 123, which is interesting. We will try to see if that is the password. This is something that we missed seeing a while ago, but no issue. We'll check if password 123 is the password right now. Just give me a second. I'll just copy these. We just need to see what these base 64 strings mean. And just copy them all. Yes. Just decode. Let's see if they are anything important or interesting. They don't look like very interesting. Internal error decoding key. Okay, never mind. Okay, so we see password 123. So let's try and see if that is the password over here. So I'll just run and I'll put password 123. It says incorrect. So this is not the password. So okay, never mind. We'll just move ahead and we see that those base 64 encoded strings are not much important to us. So we'll just quickly move and we'll see that where is the hit. And here we see correct is present, and also we see that there's a call to check remote debugger present, which is interesting. So I'll just put a breakpoint over here. I'll put a breakpoint in correct as well, because we need to see when we get those correct. Here also we can see that correct is mentioned and there is anti-query information process. We had already put a breakpoint over there as well. We need to put a breakpoint over here, although we did put, I believe, but okay, no problem. And here is debugger present as well. Luckily we saw it over here. So let's go and we get a hit over here. We have already done this before. So we'll just go to execute till return. And here we see that it is jumping to is debugger present. We'll open is debugger present in MSDN. And we'll again go through it. Like, how do we look for it? Where's the return value? It says that if the current process is running in the context of a debugger, the value is non-zero. If it is not running, the value is zero. So we know what we need to do. So we'll have to change it. And the return value is mostly stored in EAX. So we need to look at the EAX register. There is also check remote debugger present mentioned over here. Also, we'll check that as well. So we'll just execute till return, and we see the return value is 1. The value is non-zero if there is a debugger. So we'll have to change the value to 0. So we'll just double click on it and we'll change the value to 0 and click on OK, and we'll run again. Okay, so we have most probably bypassed is debugger present. Let's run again. We are in the current process. Let's move. We are in check remote debugger present. Now we'll try to see what check remote debugger present does. So check remote debugger present also determines whether the specified process is being debugged. So we need to see that what are the parameters that it has. Like there is, like it checks for the handle to the process, and again it looks pointed to a variable that the function sets to true if the specified process is being debugged. So it also has a return value, and return value is mostly in EAX register. So if the function succeeds, the return value is non-zero, just like is debugger present. And if it fails, the return value is 0. So we again have to make changes over here. So we'll step into it. We have it is jumping to check remote debugger present. So we'll again do execute till return, and we see that rax, I mean the return value is 1. So we'll again change it to 0, put OK, and then we'll just run. You can directly run or step over. So let's keep going. We have most probably bypassed anti-query information. I think it's not required at this point. Just keep going. Let's keep going. So as we continuously keep going, we see there are a lot of instructions that are coming, and if I try to click on run, I see that it exits. So it seems that we have not bypassed everything. Maybe there is something else that we need to look for, and now we have to go slightly slower, because one thing that we have understood that it had two anti-debug checks. Now we have to bypass them pretty quickly, and then we have to move on to the next steps and see what else is there. So let's keep going. So initially we'll go quickly. We'll bypass each of them quickly. I mean, is debugger deep present and remote debugger present? Both the calls will have to bypass pretty quickly. So I'll just remove my breakpoint from here. Just keep going. Yes. Okay, so we are done. Now let's keep going and see what else is there. We'll either do step into or step over. For now, I'll just follow step over. Now there are some calls. You can see that there is a call that is happening over here. So I would try to get into it. So I'll do step into to see what happens over there. Just move there, no worries. We'll just follow these calls, whichever we observe here. Like we have to get into them. Like here is call RBX. Let's see if we can get into RBX, and we can see, okay, this is ZW query information process. It's okay. We'll just move on from here. Okay, we'll get into this. Let's see if we can find. Okay, so here are two calls that we can see, some query perf frequency and perf counter. Let's see, let's get into it. And we see that there is some call that is being made over here, which is query performance frequency. So I'll set a breakpoint over here, and here we can see time get tick, which is also interesting. So most probably this is another anti-debug checks. So what it mostly does is it will see that how often timing or performance checks are getting executed. Basically, it will see that how often the program queries time, because such kind of anomalies or delays happen when a debugger is attached. We can also check this in the way we checked everything in MSDN. Just 1 minute. We'll just open it. It's the name. Query performance frequency. Let's see. So it retrieves the frequency of the performance counter. The frequency of the performance counter is fixed at system boot and is consistent across all processors. So anything else, it also gives some return value. Let's see how it works. Let's see what happens over here, because while running we'll try to understand what is happening over here. So this is the call that is happening. We'll step into, just let's see. Just move. Okay. It has a return value which is 1. It's okay. We'll not make any changes. Let's see if we need to make any changes over there or not. There is another call. Let's get into it also. This is also the same call. Let's just keep going. We'll just need to see if there is anything interesting over here. We are just going one step at a time. There is some comparison that is happening, and okay, and there's this return. Okay, return from here also. And okay, after the return we see that there is this correct whose C is not visible anymore. Let's ignore that, but there's a comparison over here. Now we need to understand what this comparison is, because it is happening after the calls. So here the conditions are such that it is assuming everything is bad by default. So what it is checking that if for example this is the comparison, if comparison RDI against this one is okay, is equal, then it's okay, else it is going to the next check and seeing if that is okay or not. So we'll just keep going and let's see how it behaves right now. So here, as we saw that the program is calling query performance frequency. Let me just come here and explain. As we also understood that it means that the frequency of the performance counter is being retrieved over here. So in very simple terms, it means that how many ticks are happening in 1 second. Okay, so then based on the count of ticks, we have also heard of, maybe I haven't shown it yet, but get tick count is also one of the way how you can check if the malware or the program is being analyzed or being running in a debugger or not. So coming back to the program, just a minute. Huh. Coming back to the program, let's understand the comparison, what is happening. At this point, this RDI, what you can see over here, is holding the clock frequency of the system and it is comparing it against this number. Let's see what that number is. It's in hex, so we'll just convert it into decimal. So I'll choose hex over here and I'll put 989680. So here you can see it is 10 millions in decimal. So that number is what is seen in most Windows machines. The high resolution timer, it runs around 10 million ticks per second, which is normal. So what this program is saying, that does the system's clock look normal? If yes, then there is some other step. If no, there is some other step. Okay, so here you can see that it is comparing, and if it looks normal, so jump not equal to. If it was equal to, that is, it looks normal, but it says it's not equal to, so it will go to the other check, which is this. Now, what this check is saying, the other one is, let me convert this as well. Let me just remove them all. 16E3600, which is 24 million. Now it is also checking that if the ticks count is around 25 million tick per second. That is also seen on some systems. If that is also present, that means that if the frequency does not match in either of this, then the program assumes that it is being run in a VM, or it is being used, like a debugger is attached. So that is the entire logic behind these. So we have seen and learnt about three different checks. Is debugger present is something that we have seen before also. This time we also saw remote debugger present, and this, and the third check that we are seeing right now is get ticks count. Actually, query performance counter, that is also checking the ticks per second that is happening. So let's just keep going. Let's see what's happening. So most probably we have to have this comparison, both the checks, so that we can get into it, because both are jump not equal to. So understanding on the basis of whatever we have learned right now, let's keep going and see how it behaves. We'll just see it returns. Okay. And we'll just keep going. So it did not do any other check. It did not go to the next check for now. It just went through the first check. We'll just see what is happening here. And there are another call to this same calls. I mean, query performance frequency. So maybe we can directly go there. Okay, we'll just get into it. Okay, there is still the same call. No worries. We'll just exit. And here you can see that there is a bigger call, which is taking us somewhere. Let's see where is it taking us to. Okay, there are more things that are happening over here. So we are here right now, and we see that there is another comparison that is being happening. This is another comparison which is specific to the ticks count. So what it does is it is doing a final check, because we have come out from there, and here also it is checking. Let's see what is this 389. Let's just 389AC A00. Okay, this is what it is in decimal. So now over here there is another comparison that is happening. Now this comparison is another check. For example, the way it was checking for the ticks count. So it is checking if the time difference is at least 1 billion now. How do I know this is 1 billion? Because I have already checked this number over here, which is nearly 1 billion. So if it will jump if it is greater or equal to. So the full logic becomes, if time difference is greater or equal to 1 billion, it will jump to that. So it means otherwise the execution should happen normally. So we have to get to the otherwise part. Let's come to this. So we cannot jump to where it is jumping at this point. We have to have this call. We need to get inside this call. Now, how do we do that? We can either set the zero flag, but nothing I think will happen. Let's see. Setting the zero flag is not helping. So at this point, what we can do is we can change it to no operations. Yes. And let's try getting to that call, which is supposedly the normal one, and hoping that we have bypassed our check. Let's see, let's keep going. This time we have to just keep doing step into so that we can see what is happening, or step over, or we have to set multiple breakpoints so that we can stop somewhere. Just keep going and keep an eye on your registers and stack everywhere, that just in case we are able to see something more. So I'll just keep going. Let me just run so that I can move on to these breakpoints. We have to come to this return value, I mean return part of it. Or maybe I'll remove this breakpoint from here. Apologies for the background noise. We'll just keep going. Let's go. Yes, it's still happening. We are still going. Let me keep going till the time I find something interesting. We can see there are some other calls that we did not see before. There is this call as well. We'll let me set a breakpoint over here. We can get inside it. We'll see what is there. But we'll go one step at a time. Let me keep going. Now, after a lot of actually step intos and step overs, I see this call and there's something that is coming over here. So let us just keep going. We'll just keep going one step at a time. Keep an eye on the stack, which is here, and you can see something is getting generated, something is getting created dynamically. So it was not present initially, it was not present statically, to be more precise, because otherwise we would have found it. It was somewhere somehow hidden or getting dynamically generated, as you can see. And most probably this seems to be the password, but we'll definitely try it out because we saw password 123 before as well. So just keep going, and I think it's creating totally secure. There's nothing else that it is creating. Okay, no, there's some other thing also, it's coming. Let's total secure key. Let's see if there's anything else. One, two. Okay, let's get to the calls. Totally secure key 123. So here you can see, here is this. Let me just put a breakpoint over here. We'll just keep going. We can, yes, we can see, we can try this password over here once, if it is working or not. Let's just try. Totally secure key 123. Correct. So we have found the password. We have solved the challenge. If you want, you can go ahead. You can see how it is still, doing the calculations and everything. We can still go on. You can directly run. And you can see that we have bypassed because this time the application is running and we are putting the key over here. So I'll just add the key over here. Correct. And here we are. So that's it for today. We'll come again with the next challenge. The next challenges would not be this complex, but they're good enough to learn. And as I already mentioned, that these challenges and whatever I am talking about in my channel is all specific to beginners. So if you are learning reverse engineering and malware analysis, please keep learning and please share your feedback. And also like, share, and subscribe to my channel. I'll come with more videos. Thank you so much. Bye.